Okay, so let's do this question. This is a very tricky question. This is a P2 Physics AS. So the figure 11 shows an aerial fixed in a vertical position by cables. You can see the cables there. The aerial transmits radio waves. Okay, transmits means it sends the radio waves out. Explain why aerials that receive these radio waves. So we have one of the aerials that transmits it, and we have another aerial that receives it. Explain why the aerials that receive these radio waves should be vertical. So now in this question, we have to explain that when the word explain comes, you have to tell the why, the reason behind it. So the one of the important reasons, if you remember, is that waves are we have vertical, we have different polarized waves. I mean, they can travel. Polarized waves means they can travel in only one plane. So the reason why we are having like why this receiving aerial has to be vertical is because the wave that is traveling between the transmitting that antenna that transmits it to the antenna that receives it, the wave is vertically polarized. That's one point. The wave transmitted is vertically polarized, hence receiving antenna needs to be vertical. And another thing that I learned, I didn't know about this, is that whenever the transmitting antenna is vertical, the receiving one also has to be vertical because this ensures that maximum amount of signal is received. If the transmitting antenna was horizontal, then the receiving antenna also had to be horizontal. But in this case, it was vertical initially, so the receiving one also has to be vertical. And what happens in an antenna is you have the antenna like this, and you have the horizontal ground surface. The signals, like they hit the ground surface, collide with it, and they're reflected onto the antenna. If we had it being horizontal doesn't make sense. It won't allow for maximum, like reception. Okay, moving on. So your question: the cable vibrate in the wind. The vibration. Wait a second. Let me just two. Okay. The cables vibrate in the wind. The vibration can damage. Let me just do one thing. Wait a second. I think this is better. Okay. Shows a damper attached to the cable. This is the damper. The ends of the damper are free to oscillate as shown. State what is meant by damping. Now we know that damping damping is when the amplitude of the oscillating wave is reduced by dissipating. Dissipating means removing. removing energy from the oscillating system. There's only one more question you can write. Damping happens when the amplitude of the oscillating wave is reduced or decreased. That's the main thing. Amplitude is the main keyword here. Okay, last question. The damper is most effective when placed at a particular distance d. Okay, so in this question we have to, if engineers determine d by modeling the harmonics that can form the cable. We know the different harmonics: first harmonic, second harmonic, third harmonic. So that's why d is determined by using the harmonic with the maximum frequency that can form on the cable. So imagine like you have this cable, you just put it like this. It's the cable, right? I'm just make the cable straight like this. Now you have one end here and one end here. If you get one loop, we know it's the first harmonic, right? But if you get two loops like this, then you know it's the second harmonic. Now if I make another straight line like this, wait a second. Third harmonic would be this kind of. Now, if you observe, like, let me just make the first harmonic again. If you observe, what we need to do in this case, we have to place a damper at a distance d from the clamp. Now, they're asking why it is d determined by using the harmonic with the maximum frequency that can fall on the cable. Now we don't, we don't know the maximum frequency that can form, but we know that there is a maximum. Now, why do we need to know the maximum frequency? Why do we have to use the maximum frequency? The reason behind this, one thing you have to write initially, like if we use like either one of them, we use the first, second, or third harmonic. The main reason we are going to place the damper at the position of the maximum amplitude. So we're going to place, for example, if you use the first harmonic, we're going to place a damper here. That's just going to be the distance. If you use the second harmonic, you're going to place a damper here. If you use the third harmonic, you're going to place a damper here. So we're going to place the damper at the first position where we have the antinode, because antinode is the position of the maximum amplitude. There's no point at putting the damper at the node, because at node we have no amplitude, so it makes no sense, because damper is used to reduce the amplitude, right? Because we want to prevent the cable from being damaged. So that's why D is determined by using the harmonic with a maximum frequency that can form the cable. So generally speaking, D will be the distance of the clamp uh, okay, from the clamp to the antinode of the harmonic. Now, why using the maximum frequency? We are using the maximum frequency because it gives us the closest or the shortest distance. If we keep the length, like as you can see, no, why are we using the harmonic with the maximum frequency that can form on the cable? Because then we can find the shortest distance. We need to find a place where, like the shortest distance possible, like where the first antinode comes, and that would be the maximum frequency. Using the maximum frequency in order to determine the shortest distance or first possible antinode on the cable. The reason being is that whenever we place this damper, it isn't always going to be that the first harmonic is going to form. Like, depending on the vibrations, we need to have the maximum frequency in mind. The maximum, like the maximum frequency or the maximum harmonic that can form. Because if we did placed it on the first harmonic, like the D distance here on the cable, and the vibrations for some reason increased, maybe an earthquake came, because I've written here earthquake, like earthquake could be a reason, or wind could be a reason. And if the maximum frequency increases, and then the cable would be damaged. That's why, to be on the safe side, we take the shortest distance from the clamp to the first antinode of the maximum frequency that can form the cable. So this is how you do this question. It's a really tricky question, but once you get it, it's quite easy.